Hey guys, so now we are going on to Algebra 3. So before I do that, I just want to say sorry for not being active enough. I've just been bombarded with a lot of assignments lately, so I've been a little bit slow on getting videos out, but now I'm back on track. I'm finding a balance, so I am ready to do this. So the topic that we're looking at today is Algebra 3. What we're going to be looking at is a little more in depth on the concepts and adding some more that you would have heard of in primary school. So what we're going to be looking at is surd equations, linear equalities, quadratic and rational inequalities, the absolute value, which is known as the modulus, some proofs and discriminants, and this will finish algebra completely. Okay, so the first topic we're going to look at is surd equations. So as you know, surds are basically square roots or roots. Roots are points that are in an equation and they represent the unknown. So if I just say 2x plus 2 is equal to 6, you obviously have 2x is equal to 4, x is equal to 2. Okay, so that would be a root. The 2 is the root of x, but let's just say in another context that you have something similar to this. So let's just say you have square root or surd of x plus 1 is equal to 5. So what you would see here is the surd sign basically just means the square root. So the square root of anything is similar to anything to the half. And that is how I remember that. But for this, how you cancel a surd is you square it, because a square root and a square basically cancel each other out, because when you multiply a half by 2, it's basically going to bring it down to 1. Do you get me? Okay, you do. Okay, so we're going to write this, and that means that we're going to cancel out the square root, and then what we do on one side we have to do on the other. So we're going to square that. Okay, so now we go down, and you can see here that the square root and the surds are going to cancel each other out. So x plus 1, and I'll write that a little better. X plus 1, and if you square root the 5, that's going to be 25. And then you're left with this. So you know that that is going to be one of your roots. But when you have a square root of something, that means that the answer either be a plus or minus of something. Or is it? No, not in this case. So one case that we would say is, let's just say this would be a case root of x, the square root of x can be plus or minus a. So why we say that is because when you have a square, it basically means that you're multiplying the same two numbers together. And if you multiply a plus by plus, it's going to give you a plus. A negative by a negative, it's going to give you a negative. So either or, plus or minus, that's why we would write that. Okay, so I'm just going to see here, can I give you another example? I can. So this is going to be a little bit of a trickier example. So let's just draw a line under that. So we have square root of x plus 12 minus 2 is equal to 2x minus 6. Okay. So the first thing I would do in this instance is try and get that surd equation on its own. So what you do is you add 2 to both sides to get rid of the 2 on this side here, this side. So now what you will get is surd of x plus 12 is equal to 2x minus 4. Okay, so as per the rules, you multiply both sides by a square, or you square both sides even. So what you're going to get now is x plus 12 is equal to, if I just do this quickly, oh my bad, hang on, there we go. If I just do this quickly, it'll be 4x squared minus 16x plus 16. Okay, so now what you would do in this instance is basically get one equation, make it all one equation. So now what we're going to say is minus x, no, that's wrong, plus x minus 12 is, no, not that, and for that side, so that means they're going to cancel out. This should be a minus as well, my bad, and on this side it's going to be minus x minus 12. So now we're going to find out what that is in a minute. Okay, so now our new equation is 4x squared minus 17x plus 4 is equal to 0. Okay, and now you can find your square roots, usual by the rule. you can either use the square root formula, but I'm gonna skip that completely. Well, I'll do it in a minute. I'm gonna show you the answers first. So we're just gonna see it here. So obviously 4, you can get 4 by 4 or 2 by 2. I'm going to use 4 by 1 first. So can we write this in a way that this will be valid? And I'll just tell you right now, you can. So it's going to be -1, no, the other way around. It's going to be +1 and it's going to be -4 on this side. So then when you multiply it out, 4x multiplied by x is going to be 4x squared. 4x multiplied by -4 is -16x. 1 by x is x, and 1 by -4 is -4. So, or it's -4. Then both of these needs to be a minus. So minus by minus is +4. So that's where we would get that. Now if you wanted to do it by the square root rule, it would be minus b, no, I skipped something there, minus b plus or minus square root of b squared minus 4ac all over 2a. And if you look at this, you're going to have your a as 4, your b as 17, and your c as 4. So it's actually -17 is b. Yeah. So from this answer here, actually before I do this, I'm just going to tell you what the roots are. The roots are going to be 1/4 and 4. So I'll just write that over here. X equals 1/4 or x is equal to 4. Okay. So now I'm going to do the square root rule, square root formula even. So we're going to have 17 plus or minus square root of 17 squared. I'm not going to bother with the minus, it's going to be the same answer anyways. So 17 squared minus 4, 4, and 4. Actually, you know what? This is going to be the same thing as 4 cubed. Hang on. Okay. And that's all going to be over 8. It's actually going to be 8. I'm just going to skip right to that. Okay. So now you just get your calculator out. That's going to be a massive number, so I'm going to use my calculator. So we're going to have 17 squared minus 4 cubed. That's going to be 225, so 17 plus or minus, actually I'm going to do this quickly, it's plus or minus 15 all over 8. So what this would be is square root 225, and that's just 17 plus or minus 15 all over 8. Okay, so now we're going to see what that is. So first of all, we're going to look at 17 plus 15 all over 8. Well, that's going to be 32 all over 8, and that is going to be 4. So we know that this is going to be correct, but just in case, we're going to do the other one. So 17 minus 15 is equal to 8, which is, no, it's not minus, it is 2 all over 8, and that is 1 over 4. So they match. Okay, so that would be how you would do the thirds. Okay. So now we're going to go on to linear equalities. Okay, so what linear equalities is basically when you're trying to find the difference, or saying if a value is this much away from its actual one, if that makes sense. So what we would say in this case, I'll give you some example. So we don't know what x is, but one thing that we are told would be x is less than, let's just say 3. That means that it will never be 3, and it'll always be either 2.9999999 blah blah blah, and all the way down to -infinity. So we know that. And that is basically what inequalities represent. It's basically saying what approximate value it will be, and or where in the number line will this lie. And the number line would just be 0, you have 3 there, 2, 1, -1, -2, -3, and blah blah blah, and blah blah blah. And that is a number line, but you don't need to take that down. I'm just going to rub all that out because it'll just make clutter. Okay, so the 4 signs that you need to know are this one, scroll down, you need to know this one, and you need to know this one. Okay, so what do all these represent? So this first one means that the number is less than, as what I showed you above. This one represents less than, hang on, or equal to. Okay, what this one represents, it is more than or greater than, and this one here is going to be more than or equal to. So those are really the only four that you need to know, and it is actually the only four that exists. So yeah, you basically need to know all of that to know about inequalities, or the basics of it anyways. So what we're going to look at first is just a little example. So let's see if I can find one. Okay, so let's start off with this one. So you have x plus 5 is less than 12. So you know that this equation, when you get its solution, you know that it's going to be less than 12. And what you want to do is to find out the value of x, what that value could be. Okay, so what you do is you basically take 5 away from both sides, so you have x is less than 7. Okay. So you know that this value is going to this value of x is going to be less than 7 when you write it on a number line. Okay. So that would be one example. Now I'm going to give you a little bit of a longer example, and I have one here. Give me 2 seconds. My laptop is low on charge, so I just need to put that on charge. There we go. Okay, so our next example is going to be a little bit of a longer one. So we're going to write this. X minus 1 is greater than 2x minus... Okay, so what we're going... Oh, and I missed out on the minus 1. Okay, so what we're going to do first is we're going to get rid of this 1. So we're going to add plus 1 on this side and plus 1 on this side. And it's actually cancelling out both of the values there. So what you have now is x is less than 2x minus 3. Okay, but that looks too weird. Hang on. Okay, alright, I went a little... Oh, sorry, no, I can keep going. Okay, so we have x is less than 2 multiplied by x minus 3. So what can we do? So what we can do is you have this 2 and you can factorize it by multiplying the bracketed terms. Okay, so what you would write is x is greater than 2x minus 6. And what we're going to say is minus x minus x. So we know what we're dealing with here. So we're going to say 2, yeah, we're going to say this. 2x, no, oh yeah, minus x minus 6 is less than 0. Now just scroll down. So now we know x minus 6 is less than 0. Add 6 onto both sides. Yeah, add 6 onto both sides. And what you have now is x is less than 6. So so that is your answer there. That is basically saying that whatever the value of x is, it is less than 6. So it will never be greater than 6. It will never be 6. It will be less than. And this basically means that we now have a real distinct root. So that is what that represents. So I'm just going to see if there's another one. No, I think we're all good. Okay, so now we're going on to quadratic and rational inequalities. Okay, so what is a quadratic and rational inequality? So a quadratic inequality is the equalities that is obviously in the form of ax squared plus bx plus c. And we're going to say it is greater than 0. That means that this equation here is going to be greater than 0. What does the sign here actually mean? So before, in the linear equalities, we saw this, 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 and this. And they mean basically greater than or equal to, less than or less than or equal to. But in terms of quadratics, what do they mean? So when it is greater than, it means that it's going to be above the x-axis. Okay? So that is what greater than means. When it is greater than or equal to, what that means is that it is on or above the x-axis. I'm just going to write on or above. So the less means is that what less than means is that it's going to be below the x-axis, and what less than or equal to means is that it's on or below. So the example that I showed you here means that this random ax squared plus bx plus c greater than 0, that means that this equation is going to be above the x-axis. Okay, so I just want to see if that is correct. Yeah, it's yeah. Okay, so now we're just going to look on an example. So let's try find one here. X squared plus 7x minus 12 is less than or equal to 0. Or will I use that? Yes, I will. Okay, so x squared plus 7x plus 12 is less than or equal to 0. Okay, I think that's the best example I could give, because what this means is that you have a 0, so it makes it a lot easier to solve. Okay, so let's try this. Okay, so the first thing you want to do is you want to try and factorize. So look at the 12 here and see which two numbers, when multiplied together, or which two numbers that multiplies to give 12 can add to give 7. So let's just say 12 by 1, that's not going to do. 6 by 2, that's not going to do. 3 by 4, that will do. So we're going to say x plus 3, x plus 4 is less than or equal to 0. And basically just take both of these out. So x plus 3 is equal to 0. X is equal to minus 3, or x plus 4 is equal to 0. X is equal to minus 4. Okay, so that would be that. And how you would actually draw this is that you now know that the equation is going to be above the x-axis. So we're just going to draw a small axis here. So you have minus 4, minus 3. So now we draw a curve, and that would be that. So you can see the shape here, it's sort of a U shape. So what this means is that the graph is positive. And what does that mean? It means that, let's just say that means that A is greater than 0 is when you have a U shape. A would represent the equation, and or is it? Yeah, this is that. So you can see that the U shape is that, and then you have A less than 0, and it's going to be an n. Now, I know it says here that it's less than or equal to 0, but in this case, what it means is that the x squared, the coefficient in front of that, is positive. So what that will mean is that it's positive. So this A that I showed you here, that's actually the coefficient in front of the ax squared. So I'm just going to write that there. Actually, no, I won't write that there. It's fine. Anyways, so let's move on to the rational inequalities. So rational inequalities is basically the inequalities where you have a fraction where the numerator and the denominator are both linear equations, or any equations that are kind of similar. Okay, so let's just try this example. So 4x minus 3 all over 2x minus 5, and that's going to be greater than 4. Okay, so I'm going to make a side note here. X does not equal 5 over. Okay, so what you would do in this instance is you want to try to get rid of the denominator whilst making a quadratic equation on both sides. So what we're going to make here is, now you could say this for linear, but why we use quadratic is it's going to have a better range. So if you just used the linear, then it's not going to give the best results. If you use the quadratic, then you have a better range and you know what you're dealing with. So we're just going to write it down here. Excuse me. So what we're going to do is we're going to multiply both sides by 2x minus 5 squared. And what's going to happen on this side is that this cancels and this squared cancels. And that's going to be less than 4 2x minus 5. So now what you do is you basically factor them all out. So you have 8x squared minus 6x minus 20 minus 26x plus 15 is greater than, what is this going to be? It's going to be 16x squared minus 40x plus, okay, so that's the equation here. So I'll zoom out. So that's the equation. So now you have that. Basically what you're going to do now is you're going to take one of these equations away from both sides. We're going to get rid of this one because it's a lot smaller. So what this will look like now is 0 is less than 8x squared minus 16x plus 45. Okay, so now what you do is you basically try find the roots. But first of all, you have 8 here. So what that means is you have a U shape. Okay, so now what we're going to say is find out the roots. So 0 is less than, so let's try find this out. So 45. So 45 by 1, if you multiply the 1 by the 8, no, that's not going to do. 3 by 15, if you multiply the 8, you multiply the 3 by the 8, that would give 24. That's not going to do anything. If you multiply 5 by 9, it'll give you 20. If you multiply the 8 by the 5, it'll give you 40. That's not going to do. Let's see here. So 15 by 3, multiply the 3 by the 8, that would give you 9. 5 by 9, if you multiply it by that, no. Okay, so what we're going to have to do is we're going to have to try find it out using these by the square root formula. So I'm just going to look that out. So I'm just going to do this on my calculator quickly. So we're going to say plus root 4 opening bracket 8, so closing bracket and opening bracket 45 closing bracket all over 2 multiplying by, we're going to find that out, and that's a math error. So obviously something went wrong. I'm going to just see what I did wrong. So if I multiply that out again, it's going to be 10, 20, okay, this should be 80. So that should be minus 80x. And this should be 100. But that's where we went wrong. So now we're just going to go back through it and we're going to correct what we did wrong here. So it's going to be 0 greater than, the 8x squared still stands. So it's going to be minus 54x plus 85. So we're going to see if we can get anything out of it. So you could say, does 85 divide into 3? I'm just trying to find any answer I can get. So I don't think we're going to be able to use that. So we're going to have to use the inequality rule. So we're going to say 54. So we're going to say 54 plus square root of 54 squared minus 85 all over 2. So that'll give x. So the two roots is going to be x is equal to 4.5, or x will equal to, now just go back and change the plus to a minus, and that's going to be 5 over 2, which will be 2.5. I would just use the fractions because they look so much better. Okay? So I just use that, and those would be your roots. So that is where you put your points for the graph. So we know it's going to look like this. And it's a U shape, so it's positive, and it's and that is basically it. So that is rational inequalities. That's when you have two fractions and both of them have a similar linear expression, and you basically just find out its roots, find out if it's positive or negative, and yeah, then you're good to go. So now the next part we're going to move on to is the absolute value, which we call a modulus. So this would be a modulus. Okay, so that is a modulus. It's a number that lies between two lines, and the line basically represents how many units away that the point inside is from the origin, and the units will never be a negative, so this is 7 units away. So that is how you would know that. Okay, so now we're just going to try find out all of these, or I'm going to bring it more into examples now so that you know what to do. So when you're using it with the x value, it would basically be the same. So you have minus x, and that's going to be x units away. Okay, so we're going to find out. So we're going to do an example. So let's just say, so find the two values of x if x plus 1 is equal to 3. If the modulus of x plus 1 is equal to 3. So in this case, you're going to have two different examples. So the inside answer, so this could equal minus 3. No, the inside could equal minus 3, or the inside could equal plus 3. So we're just going to write x plus 1 is equal to 3, or x plus 1 is equal to minus 3. And those are the two that we're going to use, and now you just take one away from both sides of each one. So you're going to have x is equal to 2, or x is equal to minus 2. So those are going to be the two values that you have inside, and either of them can suit it, and because each of them are going to be 3 units away. So let's just say you put in the 2 up here. Oh no, hang on, sorry, my bad. Okay, so let's say, so both of these values are going to still give these number of units away. So if you put the 2 back in, it's going to be 2 plus 1, that's 3. The modulus of 3 is 3. And if you put in the minus 4, it's going to be minus 4 plus 1, that's minus 3. The modulus of minus 3 is 3. So that would be how you would get that. In terms of where it lies on the graph, that's just the same thing, knowing what point that it lies in. So then you know what length it's going to be, or how many units it's going to be away. So yeah, I can move on. So we're going to look at this in terms of the inequality. So if we look at modulus inequalities, then you can say this. You can say modulus of x is less than 4. That means that the unit length away is going to be 4. So what you would say is, you know that this x, the x in here, since it's 4 units away, it's either in between minus 4 and 4. So what we're going to say is minus 4 is less than x, and x is less than 4. So we know that for a fact. Okay, so now we just look at this, and now you just look at it and you say, okay, if x is greater than 4, then the x is going to be 4 units away from 0 on the number line. So that is technically correct. If it's greater than 4, it's still going to be 4 units away, or it's going to be 4 units away anyways. So in this case, it has to be in between, because then it'll be exactly 4 units away. Instead of the modulus of x, I might have just confused you there. So if this was greater than 4, then it's not going to be 4 units away, it's going to be more than that. So it has to lie in between minus 4 and 4. So x is going to have a value that is less than minus 4 or greater than 4 if the modulus is greater than 4. But it is not, so it's going to lie in between that. I must have confused you there, I'm sorry, but what we will do now is give an example. So x plus 3 greater than or equal to 5, the modulus of x plus 3. And what we will say now is, we know that this is now going to be either less than or equal to minus 5, or greater than or equal to 5. So now we're just going to write that. So it's so x plus 3 less than or equal to minus 5, and x plus 3 is greater than or equal to 5. So that means that it's going to be more than 5 units away from the origin on your number line. So how you would find it out for x is, what I would actually do is just skip writing this and just multiply them both sides by a square root. And what this means is, because it's going to either be minus 5 or 5 or in between them values, it doesn't really matter, because minus 5 by minus 5 is 25, 5 by 5 is 25, so it doesn't matter. Okay, So now you're going to have x squared plus 6x plus 9 greater than or equal to 25. So now you're going to have x squared plus 6x minus 16 less than or equal to 0. And what you can do now in this stage is use factorization. So it's going to be x minus 2 and x plus 8 greater than or equal to 0. And now you find out what x is going to be. So x is equal to 2 or x is equal to minus 8. So that would be those values. And those are your roots for this quadratic. And that means that this is where our inequalities are going to lie. So if you sketched it, I'll show you here. Let's say you have minus 8 here and you have 2 here. Now you just draw that. So what we're going to say is this area here that I'm writing in red, that basically represents the units away that we were asked originally. So we know now that these roots are going to be this certain amount of units away from the origin, or the middle even, and everything in red is going to be anything greater, any amount of units greater than that. So that is basically what that represents. Okay, so now we're going to go on to proofs. So if we just look at proofs and just see what they are. Proofs are basically proving what something is. So in inequalities, we're going to be asked to prove if something is true or false. That's going to be the proof. The proof is whether it's true or it's false. So let's just give an example here. So let's just take a negative real number. So minus 2. So what you're going to have is minus 2 squared is equal to 4, and that is greater than 0, or greater than or equal to 0. Okay, so this would be an example of something that is false. You know that 4 is greater than 0, not greater than or equal to 0, so it is going to be false. Another one is just a neutral number, so 0. If you square 0, that's going to be 0 greater than or equal to 0. This is true because 0 can be greater or equal to 0. So you would say that, okay, this is correct. Okay. So if we take it in terms of letters, we say, prove that if a and b are real numbers, then a squared plus b squared is greater than or equal to 2ab. So I'm going to write that down. A squared plus b squared is, greater than or equal to 2ab. So I'm just going to write that down. Okay, so what is this going to be? So now what we would say is, so we're going to say a squared plus b squared minus 2ab is greater than or equal to 0. And we know that, yes, they are, because let's just say we take 1 for a and 1 for b. So you have 1 plus 1, that's 2, minus 2, that's 0, that fits it. And you could say minus 1 and minus 1, it's going to be the same thing. So, and if you said 2 and minus 2, it's going to be 2 squared plus 2 squared, that's 4 plus 4, 8, minus 2, bracket 2 and 2, that's 4, so that's 8 minus 8, and it's always going to be equal, no matter what the situation is, this will be true. So that is always going to be true, since a real number squared is always going to be greater than or equal to 0. So that would be an example of that. That was very quick. Discriminants. What discriminants are is basically, okay, let's just look at this first of all. So when we were talking about solving roots, I gave you this formula. I keep forgetting the plus and minus. Plus minus square root of b squared minus 4ac all over 2a. So basically what this means is solving its roots. But let's look inside this surd here. So now you can say b squared minus 4ac. Okay, so what I'm going to say to you guys is this is the discriminant. The b squared minus 4ac is the discriminant. This means that this basically determines where it lies on the x-axis. So let's just say this. So I'm going to give you 4 examples. So b squared minus 4ac greater than or equal to 0, b squared minus 4ac greater than 0, b squared minus 4ac less than 0, b squared minus 4ac less than or equal to 0. Okay, so what do these mean exactly? So when you have b squared minus 4ac, you're going to have real roots. So that means that the number is going to be real, and it's going to be plus or minus, whichever one. But what we know is b squared minus 4ac is going to be a positive number. So what we say now here is so what we say here is that there are going to be real roots associated to this area here. So I'm just going to say or for real roots. Okay. This second one, b squared minus 4ac is greater than 0. That means you have real roots plus distinctive or distinct roots. So dr. So distinct roots, that means that it's going to be greater than 0. There's no less than or equal to or anything. There's no greater than, there's no equals to, it's just greater than. Or greater than, or there's no greater than or equal to, it's only greater than. So this next one here, b squared minus 4ac less than 0, doesn't exist right now. When we get to complex numbers, I will show you. But for now, don't take notice to it, so I'm going to cross that out. So that basically means b squared minus 4ac less than 0, there are no real roots. They're complex roots, and they'll come in a later chapter. And when you have b squared minus 4ac less than or equal to 0, that also says that it has no real roots, but it could be equal to. So what I'm actually doing is going to cross that out. And the last one is, actually, though I missed it, b squared minus 4ac is equal to 0. That means that we have real and equal roots. That means that the roots are going to be the same as 0, or any number that you put in there. Okay, so if I just draw this on a axis, so I'm going to take the 3 of them. So when we say it's greater than 0, then it's written as so, where you have points alpha and points beta. So let's just write that. It's less than 0. Okay, so that would be how you would represent that, and that is when a is greater than 0. And how you would write it when it is less than 0 is the other way, inverted, where you have point alpha and point beta. Okay, so now if we look at if it's equal to, then what you're going to see is that it lies right on here, where you have point alpha, and that's a, what happened there? And that's when it's a greater than 0, and if it's less than 0, then it's going to invert itself. And when it is less than 0, it's like so, then what you're going to get is a graph that you're going to see in a later chapter. So when it's greater than 0 and less than 0. Okay, so that would be how you would see that. So I'm actually going to draw these better because they look very sad and horrible. And okay, there we go. So that would be what that is. And we'll just take an example before I finish. Find the value of k if x squared plus 6x plus k is equal to 0. So you need to look at the third formula, or you can just look, yeah. So what you say is a is equal to 1, b is equal to 6, and c is equal to k. So what you say is b squared minus 4ac AC is equal to 0. And you would say 6 squared minus 4 1k is equal to 0. And what we're writing is 6 squared minus 4k is equal to 0. 4k is equal to 36. K is equal to 9. Okay, so you know now that this is going... So obviously, as you saw there, this is an example of where it's equal to 0. You could say that it's greater than 0. You can change the sign here. You could say, it's less than 0, because this will actually make a lot more sense. So then you say it's greater than 9. You could say that it's greater than 9, or you could say that it's greater than 0. So that means it's less than 9, or and so on and so on. I'll just keep that there. Okay, so that would be an example of a discriminant, and it's one of the easier examples. Before I go on too much longer, I'm just going to end it there. So thank yous for tuning in, if anyone did tune in. And the next topic we're going to be looking at is going to be length, area, and volume. So I will see you then, and I will see you